Welcome to Plutus STEM, and today we are covering a topic from the Coordination Chemistry class 12, that is EAN rule. Now, what does EAN rule means? EAN rule refers to the full form of effective atomic number, that is refers to effective atomic number. What does effective atomic number means? Effective atomic number you can understand as that it is similar to the octet rule that we study in chemical bonding for the elements. Similar to octet rule. So what does octet rule state? Octet rule says that any element that has a complete 8 electrons in their valence shell except for hydrogen, 8 electron in valence shell, that means they will be completely stable. But EAN rule takes a different approach. EAN rule is used on EAN rule is used for coordination compounds. Coordination compounds. Now, it states since for the formation of the coordination compound we require the valence shell contains a total of 5 d orbitals, 1 s orbital and 3 p orbital. That means here we have a total of 9 orbitals that forms the complete valence shell orbitals that forms the complete valence shell. Now, if this complex is completely stable, but that means if I fill this shell completely, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this, and all the electrons that are previously filled will previously filled. So here we'll see that this, after filling this last electron in the p subshell, it attains the noble gas configuration. Noble gas configuration, and like any other compound that attains noble gas configuration, it becomes completely stable. So the EAN rule states that when the total number of electron in a complex become equals to the noble gas configuration, it helps us to define that the particular complex will be stable in nature. Here, for the 3D series and 4D and 5D series, we have krypton, xenon and radon. Krypton has an electron count of 58. This has a 87. I think 5D, for the 5D it is enough. So that means you need to find the total electron count for that. So EAN rule can be find EAN number. Effective atomic number can be found by using the total electrons of the element, that is equal to the atomic number of the element. Atomic number plus any positive charge that it has, that means it has lost some electrons. So any positive charge that it has get, subtract, it will be minus number of electrons lost, or you can simply mark it as, or positive charge that it has on it. Then add any negative charge that it has plus electron count of the ligand, electron count, multiply the number of ligands that you have. Wait, let me correct it. Krypton has an atomic number of 36. That's the correction. Well, xenon has of 58. So here, for example, if I say that I have a complex of Fe with carbonyl, and I need to find how many number of carbonyls I require to form a stable complex with Fe. So here, Fe belongs to the 3D series. It has total electrons equals to its atomic number, which is 26. While every carbonyl, like any other ligand, will provide 2 electrons. So if I assume this complex to be stable, the total electron count must be equal to 36, which is the next nearest noble gas to Fe. Fe has 26, and since carbonyl is a neutral ligand, there will be no positive or negative charge on the iron. 2 electrons with x number of electrons. So 36 minus 26 will be equals to 2x. So it will give us 10 divided by 2 equals to x. So x is equals to 5. That means for the stable complex of Fe, I require a total of 5 carbonyl ligands, and that it is obeying the electron effective atomic number value. That means the total electron count is equals to 36. Now, I can also check the stability of a complex, for example, Ni carbonyl 4,4, whether this complex exists or not by simply checking the EAN number. So, nickel has an atomic number of 28. I have 4 ligands that are contributing 2 electrons. Again, it is a neutral ligand, so no positive or negative charge. It is 28 plus 8, which gives us a total electron count of 36. That proves that NiCO4 does exist, but nickel carbonyl whole 5 do not exist because it violates the EAN number. Hence, the stability of this complex is very much low, and if you simply heat it, it will decompose to give you a stable complex, removing carbon monoxide as a gas. So I hope you have learned something new today about the EAN rule. In case of any doubts, you can add it to the comment section and we'll get back to you. Okay, but one more thing before we leave, that EAN rule is not an absolute number. For some complex it may vary, for some complex it may not be followed, but it gives us a clear defined pattern that if you want to a generalized version, that if you are looking for a stability of the complex, you can look for the electron count of the complex. And that's it about for today. Thank you for joining us.